Hi, it's me. When most people think of the largest eruption in history, their minds immediately go to the Big Blast, the cataclysmic explosion at Mount Vesuvius that buried the Roman city of Pompeii under 4 to 6 meters of ash. And while it's true that this event was catastrophic for humans, it was by no means the largest volcanic eruption in history. In fact, there is an even bigger, more powerful blast hiding in plain sight, the super-eruption of Yellowstone. The Big Sky country is home to one of the world's largest active volcanoes. Over the last 2 million years, it has grown so large that it created its own caldera, a massive crater stretching over 43 miles across. But what makes Yellowstone special among all the other supervolcanoes on our planet? It's not just its size, it's also the frequency of its enormous explosions. While most supervolcanoes only erupt once every 100,000 years or so, Yellowstone has done it 3 times in the last 2 million years. That's a rate of eruptions once every 600,000 years, which makes it the most active supervolcano on Earth. And if you ask me, we are long overdue for an eruption. The last time the beast blew its top was 640,000 years ago. That's nearly 100,000 years longer than the time period between the first and second eruption. We may be approaching the point where the volcano awakens once again, but whether or not that happens anytime soon isn't the focus of today's episode. Instead, I want to tell the story of Yellowstone's hidden eruption, the blast that left an even deeper crater underneath the existing supercaldera. To find the missing piece of Yellowstone's past, we need to look beyond the geological record found within the borders of the United States. This is because the true beginning of the Yellowstone supervolcano actually started with the formation of a massive magma chamber beneath what is today the Yellowstone Snake River Plain. Between 13 and 14 million years ago, molten rock began to pool below the eastern edge of the Idaho-Wyoming border. Over hundreds of thousands of years, this magma chamber grew larger and larger until it was over 100 kilometers across. As it expanded, the magma ignited previously deposited pockets of oil and gas, creating enormous underground explosions that vented material to the surface. Some of these explosions were so powerful that they left their own craters on the surface, such as the Bruno-Jarbitis basalt group, a series of overlapping calderas that extend from Idaho into western Wyoming. As time went on, the magma chamber grew to such a size that it became the foundation for a new mountain range known as the Rocky Mountains. However, this was not the end of the Yellowstone story because as the Rockies rose higher, the magma chamber continued to grow as well. In fact, it would continue to grow for another 7 million years until suddenly, catastrophically, it erupted. The explosion was so violent that it ejected 2,800 cubic kilometers of ash and pumice. To put this number into perspective, the big blast at Vesuvius only ejected 24 cubic kilometers of material. That means Yellowstone's eruption was 117 times larger than the eruption that destroyed Pompeii. However, despite its sheer size, this event didn't leave behind much evidence of its existence. The reason why? The magma that was ejected during the eruption was mostly silica-poor basalt. Because of this, it quickly hardened into black glass called obsidian. Today, the pieces of this hardened lava are so small that they have been mistaken for dirt. In other words, when geologists search for evidence of the eruption, they essentially have to sift through millions of tiny shards of glass to identify which ones are older than the surrounding bedrock. As far as we know, this eruption didn't build any new mountains. Instead, it emptied its energy in a wide-angle plume that spread out over a very large area. Most of the ejected material landed somewhere in present-day Idaho, but some of it traveled all the way to the Gulf of Mexico. It wasn't until after the eruption that the Rocky Mountains began to rise up around the magma chamber. Since then, the weight of the overlying rock has squeezed the surviving magma back into a new chamber, creating the foundation for what would become the modern Yellowstone caldera. What happened next, though, was a surprise to scientists. Instead of building a new mountain, the magma produced a massive flood of lava. In fact, it was the largest lava flow in the history of the Rocky Mountain region. At its thickest point, it was over 1 kilometer high, and at its widest point, it was over 18 kilometers wide. It flowed east from the base of the Yellowstone caldera until it reached the Snake River, which it promptly dammed up, creating a giant lake. As the lava cooled, it created a new mountain called the Black Hills, but only raised the land around the magma chamber by about 30 meters. The reason why it wasn't much taller is that the underlying magma chamber was extremely hot. As the lava flowed from the vents, the heat from below kept the lava too runny to build anything significant. What scientists realized is that the temperature of the magma chamber played a major role in determining the shape of the new mountain. Since the chamber was too hot to produce viscous lava, the resulting mountain would be wide and gentle rather than tall and steep. Scientists were able to determine the temperature of the magma chamber by studying a type of rock called rhyolite that crystallized at the edges of the lava flow. Through careful analysis of these crystals, they determined that the magma chamber was about 1,150 degrees Celsius, which is nearly 1,000 degrees hotter than the average human oven. With a chamber that hot, it's no wonder the lava flowed so easily. Today, the remnants of the Black Hills Mountain can still be seen in southwestern Wyoming. From a distance, it looks like a flat-topped hill, but up close, it's clear that it's actually a jumbled mess of solidified lava. It's full of cracks, holes, and other features that make it look nothing like the nearby Absaroka Range. In fact, you could spend your entire life exploring the wilderness around Yellowstone and never realize that the Black Hills are actually a remnant of the second largest eruption in company history. For about 600,000 years, the magma chamber continued to accumulate heat until once again it burst forth in an enormous eruption. The blast ejected 500 cubic kilometers of ash and pumice, which is almost double the amount from the previous eruption. This time the eruption was more explosive because the composition of the magma had changed. While the magma that produced the lava flow was mostly silica-poor basalt, the magma that erupted in the second super-eruption was silica-rich rhyolite. Not only that, but it was incredibly viscous, sticky, so much so that it behaved more like peanut butter than lava. Most of this thick lava built up around the vent, forming a solid plug that blocked the escape of gases. As pressure built behind the plug, the magma chamber began to bulge upward. Eventually the pressure was strong enough to blow the plug apart, causing an enormous explosion. Like the previous eruption, this blast did not build any new mountains. Instead, it sent material flying in all directions before hardening into ash and pumice. What's interesting is that the pumice formed in layers. Each layer was created when the gas pressure blew apart a lava plug, sending pieces of the plug flying into the air. These chunks of solidified lava eventually weathered down into small pebbles, and over the course of the last 500,000 years, these pebbles have been eroded into a vast blanket that stretches over a large portion of the modern caldera. What's even more interesting is that scientists have been able to identify different units within this blanket based on the chemistry of each layer. They've identified 10 separate eruptions, each separated by periods of calm. These 10 eruptions occurred over a span of 46,000 years and ejected a total of 1,600 cubic kilometers of ash and pumice. All told, the total volume of material ejected during the second Yellowstone super-eruption was approximately 1,600 cubic kilometers. To put this number into perspective, the big blast at Vesuvius only ejected 24 cubic kilometers of material. That means the Yellowstone eruption was 66 times larger than the eruption that destroyed Pompeii. It might seem like this eruption should have left behind an obvious record of its existence, but the truth is that the majority of the material ended up in the ocean. For this reason, researchers were able to learn about it by drilling deep into the ocean floor off the coast of North America. In fact, sediment layers from the eruption were discovered in the bottom of the Atlantic Ocean, all the way from Greenland to the Caribbean. Today we can see the remnants of the second Yellowstone super-eruption from space. The rim of the caldera is clearly visible in satellite images, but from the ground, it's not so obvious. That's because the second super-eruption didn't leave behind much in the way of physical evidence. Aside from the 10 individual lava plugs, the only remaining feature is a layer of ash that now forms part of the soil. According to geologist Jacob Lowenstern, you could literally drive right by the site and not realize you were standing on top of one of the largest eruptions in history. The second Yellowstone super-eruption ended the first phase of Yellowstone's eruptive history. It also ended the relative peace that had settled over the region since the formation of the Rocky Mountains. This was because the second super-eruption triggered a huge landslide that dammed the Snake River, creating the modern Yellowstone Lake. The landslide also exposed the magma chamber that lay beneath the lake. Hot water from the lake seeped into the magma chamber, cooling it and changing its composition. The result was a new type of magma, one that contained enough silica to produce highly viscous lava. This new magma would eventually build up enough pressure to trigger the third and largest eruption in Yellowstone's history. And to learn about this event, please stay tuned for my next video. Thank you for watching.